Google just dropped its agent-to-agent protocol, and I'm all for it. Now, to be honest, I was really hyped for MCP as well, but after using MCP for a while, I realized that there were some gaps with it. And, well, Google's A2A fills those holes. Wait, that doesn't sound right. Let's just dive right in. Obviously, they announced it in a very MCP fashion as well. They just have a blog post. If you go through the blog post, you realize it's absolutely stupid, so we're gonna skip it. We're not gonna refer to this blog post. We're not gonna refer to this blog post at all. Instead, we're gonna go to a handy tool like scalable. Yay! This is the one. Where are my libraries gone? I need the most important library. I mean, cannot live without this one. Most important library. Don't you judge me. Well, okay, let's start with an example. Our example is that we are an engineer and we have been given this ridiculous assignment of finishing an entire project by the end of the week. Now, the project could have multiple tasks. It could have a lot of things going on, but we need to finish it by the end of the week. Hey, life is complicated. Can't help it. Now we have an assistant which helps us manage our tasks. So it's kind of like a project management assistant of sorts. But yeah, that's what we have. Cool. The only question we want to give the assistant is, hey, schedule all my tasks for project A this week itself in my calendar. What does the assistant do? Assistant obviously is aware of the fact that we have Notion for project management and we have Google Calendar for our calendar stuff. So what will our assistant do? The first step the assistant probably needs to do is, hey, give me all the tasks for project A. And Notion, being a good boy that it is, it's gonna give us back, sure, you have 2 tasks. You know what, let's just even expand a little on this. We have 2 tasks and the task A is, let's say, an hour long, and let's say the task B is 4 hours long. And let's modify this question as well with estimates. Okay, we got 2 tasks that, okay, we have task A and task B. Now the assistant will be like, wait, we have all the tasks now, so we need to like schedule this in our calendar. So what it's gonna do, it's gonna be like, hey, Google Calendar, schedule these tasks. And Google Calendar is smart. So Google Calendar will have to use its brain and be like, oh, I have a 1 hour task, I have a 4 hour task, so I need to find free slots or blocks of time which is available on the calendar and then schedule it accordingly within the time frame of the week, right? Let's say the agent schedules task A, but we have a problem because the real world has a thing about lemons. It just loves lemons, and it's really hard to make lemonades out of those. So what's going to happen here is it might schedule task A, but for task B, it might go like, hey, we don't have a 4 hour block free. That can happen. And that's how the real world works. Now what happens? Now, what if we go back to Notion and we go like, can we break task B down? Can we break it down and just make it a little bit smaller, make it doable? Now, Notion, because it's a project management tool, it might have a concept of subtask. It might not have, we don't know. But, let's assume a happy path here. So Notion goes back and says that actually we can. And it gives us a subtask. And now we go back to our Google Calendar and tell it, schedule these instead. And why is this arrow escaping from me? Stay here, buddy. Stay here. And now obviously you can end it by saying that, okay, calendar actually went ahead and scheduled it, right? So practical example. Guys, does this make sense? We're trying to take a practical example where things can go wrong and you might need some interactions. Actually, you know what? I'm not done here. A big problem with agents, again, talking about practical stuff, just look at this guy. You think this guy is going to wait for like a minute to get its answer? Just look at him. That's not happening. So this entire wait time, which we have here, right? It's not acceptable. I mean, we have reports which says every 100 millisecond of latency causes 7% drops in traffic. That's crazy, right? This is like a lot of things. A big revelation I've had is that humans are monkeys. They're really impatient. They want their answers now, but they're kind of stupid. So let's say you have a button and you click a button and that button takes like 300 milliseconds to answer, you'll get annoyed. But if I click a button and you get like a loader sign right here, right next to it, and even if the request takes 400 seconds, you'll be 20% more likely to wait for it just because you got some instant feedback. So the point is, humans are okay with waiting as long as they know something is happening. So as long as this guy knows that things are going on and it's sort of in the right direction and there's a way to monitor it, you will wait. I mean, there are higher chances you will wait rather. So we need feedback which goes like, hey, got 2 tasks. And then we could have another feedback which says no free slot. And then go like, oh, we can break it down. And you might want to be a little bit more insane. You might actually say, oh, you know what? Let the human answer first. So you could be like, hey, human has to confirm that task breaking is allowed. And only then can you go and schedule it. And then you get the final answer saying that, okay, it's done, right? This is the human in loop part. So when I was building Fluid Cache, I realized that there's a lot of these patterns which happen. There are some interactions which can be autonomous. There are some interactions wherein the human has to get involved. But no matter what happens, you have to make sure that a human is getting enough feedback. They're in loop so that there's patience and they wait for it. Out of this example, there are 4 important points which come out. The first one is that we need a standard way to give tasks, right? So in this example, we're giving the Notion agent a task and we're getting back a response, right? So it's like a request response thing, kind of like a function call. And maybe we already have a protocol to do function calls. So this kind of looks similar, maybe, probably. But we're not just submitting tasks and getting responses. We are actually even having some long running tasks. Like, look at this one. Like when I started this question, like schedule these tasks, we were not able to schedule it. In fact, we had a follow-up question, right? So the second requirement that we come into is that we don't only want an ability to send tasks, we actually want an ability in which my agent can ask follow-up questions regarding those tasks, right? So we're not just asking tasks. We want the agent to have a capability where it can ask follow-up questions if the instruction wasn't clear enough or something goes wrong, right? So it's not just a request response, it's a request with follow-up questions, maybe, probably, something like that. And we need a standard way to do that as well. Cool. The third one would be, we need a standard way to send events. We need a standard way for eventing. Like, how does this assistant know that, okay, we can send an event at this point? Like, these are some status updates to give to the user. How does the assistant decide what to show to the user and what not? Because you might not be showing an update for every interaction, right? You might want to just do it for specific ones. So you need a standard way in which an agent can publish task updates or events, which the user, the end user, or maybe a third party can subscribe to. I think that's a very important part of agents. But none of this would work unless the assistant could figure out what's the capabilities of these agents. So the agent needs a way to discover the capabilities of others as well. Obviously, I think that should have been the first task. You know what? I should have probably started with that one. My bad. Okay, 4 things. We need a standard way to discover capabilities. We need a standard way to submit tasks. We need a standard way to ask follow-up questions. And we need a standard way for events. Okay, 4 things. I counted it right. I'm glad. Obviously, A2A does a lot more, but I think these 4 are fundamental. So I'm going to be focusing on these 4. All right. So now let's have a look at A2A's features and how does it satisfy those 4 requirements that we just presented or we just created for ourselves, right? So the most important part of A2A is definitely something we call the agent card, which describes what the agent is all about. Let's just go through it, right? So every agent has a name, every agent has a description, a URL on how to reach it, maybe some provider details, version, blah, 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 some standard stuff. Then it has capabilities. I think that is very important, okay? This is like amazing. Like capabilities is amazing. So essentially, this is the agent telling the client that, you know what, I support streaming. I support something called push notifications. And I also support something called state transition history. As in, whenever the state of the task kind of changes, I'm going to send you an event, something like that, you know? So the agent can upfront tell the client whether I support it or not, which is great. And the client can even choose whether it wants it or not. You know what? Just remember this. It supports streaming, supports push notification, and supports straight transition. All of these are important things. We'll look at all of them in just a bit. Then authentication. I mean, cool, I guess. I don't know why a lot of people give a lot of slack to MCP that it doesn't support authentication, but I mean, to be fair, authentication isn't that big a deal. This is just describing how it can potentially authenticate. It's a good feature, but it's not going to take care of authentication for you. You still have to like implement it. This is just going to tell you that, oh, you know what? This agent supports the basic authentication format or the bearer authentication format. The schemes that it supports is all described in OpenAPI. So again, if you've used any SDK and things like that, and you've been setting headers, this just tells you what header to set and how. That's pretty much it. Yeah, cool. Not that important, but sure. The second more important thing is input and output modes. So it's essentially saying what kind of inputs and outputs it supports. Because remember, agents can use image inputs. It can use video inputs, audio inputs. It could be multimodal, right? So this is just saying that, hey, I support multimodal inputs or not, and I support multimodal outputs or not. Something like that. And this is the game changer part. Okay, this is a big differentiation factor, especially if you're comparing it to MCPs. An agent doesn't have tools. An agent has skills. So what is a skill exactly? It's kind of like the capabilities an agent has to offer, something of that sort. I think the best way to explain this would be to see an example. So in MCP, we have a concept of tools, right? So tools are analogous to functions. Functions have strict inputs and strict scopes. But skill is more like a capability wherein you're not describing what an input looks like. Like nowhere here are we describing what's the input schema. Like what are the parameters to pass. Nowhere do we describe that, okay? Instead, what we are just doing is we are saying that, okay, I have a skill with this name. The skill has a description. These are some example prompts, right? These are some example prompts you can send. And these are the modes. These are the modalities we support. So it's very loose. The scope is not very well defined. It's very similar to how you would talk to an LLM, right? You don't have fixed schema to talk to an LLM. You just use natural language. And this is pretty much like that. I think it would help if we see an example. So if I skip all of this, we go to an example and what is this? Wait, what? What? Guys? I think we'll have to subscribe if you want to watch, if you want to see the examples. I'm sorry. I didn't decide this. It's Google. They decided this. You have to subscribe if you want to see more. So please subscribe. It really helps. And like this video while you're at it. It really helps. It really helps. Okay, let's refresh so that we get rid of it. So this is an example of the agent card. All right. The name and stuff, not that important. But yeah, look at the skill. So again, in your mind, if you know MCP, start comparing it to the MCP tools and, some bells will start ringing. So it's a Google's map agent, right? So Google Maps, the app, it's an agent for that. And it has a route planner. What is a route planner? It helps in planning routes between two locations. Okay, cool. But now look at this. This is where things get interesting. Look at the examples. Plan my route from this place to that place. What's the commute time from this place to that place at this particular time? Create turn-by-turn directions. You see what's happening here? The route planner is a very generic thing. It just helps planning route between two locations. But how can you use it? You can use it to plan routes from one location to another, similar to what the description says. But you can also use it just to get the commute time. So instead of actually planning the route, you can just use it to get the commute time. And you can also create step-by-step or turn-by-turn directions as well. So essentially, this skill is giving me prompts which I could pass to this agent to make it do work. Again, there is no specific function that I need to call. I don't need to decide, what skill to use or what not. I'm just giving the agent a prompt. And it's kind of even giving me example prompts to figure out that, okay, I can use it for this. So it's more, I really don't know how to describe this. But especially when you compare it with MCP tools, which are very strict and they do one thing and, they do one thing well. This is more like, hey, you know what? I'm a guy who can plan routes, but you can ask me questions like this. So feel free to experiment, I guess. And you can play around with it. You can try different things. You can mix things together. And I'll try to the best of my abilities to answer it. So the scope of the skill that it's actually going to do is very fluid. So a skill is not as strict as a function. It's a more fluid way to describe capabilities, I guess. I don't know how to describe this, but this unlocks certain patterns, right? This means your client doesn't have to do that much work to figure out what to do. I mean, all you need to do is get a question. And this question doesn't even have to be from an agent. This question could be from a user directly. You could just take a user's question and give it to an A2A server directly. You don't really need an LLM in the middle to figure those things out. Does that make sense? Am I doing a good job in trying to explain what a skill is? So these examples, so remember when you saw Notion here, right? And this estimates part, which I said, how will we know that we need to ask it with estimates or not? This would be a sample example in the agent skill list. So this Notion agent would have skills and it would say that, okay, you know what, I have a skill where I can help you get all your tasks. And there would be an example which says that, oh, you know what, you can get all tasks, you can get estimates, you can get time. So those would be different examples. And this is a hint for this assistant to make those questions. So you don't really need to know what an estimate is or what that is. You just have those sample prompts, and using those sample prompts, you can kind of infer that, oh, this is how I can ask it questions, or this is the kind of questions it can potentially answer. So it's very fluid. It's very fluid. And I kind of like that. I really, really like that. Especially when you're working with humans, because most humans will give you inputs in natural language. And now you don't have to convert that natural language into structure at all. You can just pass it to the agent in natural language, which is pretty cool if you ask me. Okay. I am actually getting no ones. So I'm going to assume that we follow along, I guess. All right, cool. Actually, you know what? I missed something. I just realized we saw the agent, right? So an important point will also be, how do you discover agents? Like, how do you know what an agent is and things like that? Or how do you even get this object back, right? Like, who is describing this JSON? Where is it there? So A2A is pretty comprehensive. It has a separate section on just discovery. So it has like 3 ways you can discover this file. So every website, let's say I have fluidcast.ai. So every website like fluidcast.ai would have this URL, and that URL essentially would return that JSON. That's one way to do it. Another would be, you could have a registry. You could actually have a registry, where you could query. You could have a REST call, and that gives you a list of agent cards, right? This registry could be built by you, hosted by you, or you could use an open source registry, which is hosted by somebody else. It's totally up to you. Private discovery. The point is, there are multiple ways to discover agent. Really cool. I mean, good to have, I guess. Sure, probably. MCP is going to have a registry or something like that really soon as well. Okay, cool. We satisfied the first ask we had, right? That how do we explain what capabilities each agent has to offer? Now, the question is, how do you actually do these tasks? Like I said, how are you actually submitting this task and getting a response? 1. 2, how are you submitting that task and getting that follow-up questions and things like that? The second requirement which we had, I don't even remember the requirements at this point, but how is that protocol working? Oh, what is this? Wait, what? Oh, okay. Interesting. Vancouver is such a weird place. It is 6 p.m. right now, and there is sunlight on my face. How is that happening? I don't understand this. Okay, great. Cool. So let's proceed to, how do we give each other tasks, right? How do we actually communicate with an agent? And this is where things get interesting. So A2A has a concept of task. Let's dive into it. A task is a stateful entity that allows clients and remote agents to achieve a specific outcome and generate results, right? Ask questions and get answers. Client and remote agents exchange messages. Okay, so the concept of messages. So instead of fixed schemas of functions, so instead of fixed functions signatures, we have messages here. So clients and remote agents exchange messages within a task. Remote agents generate results as artifacts. Very, very important. Okay, artifact. So a task can have messages, a task can have artifacts. Right? Any output which is created as an artifact. So this was an artifact, because we are literally saying that we have 2 tasks and this is the first task, this is the second task. That's an artifact. Special nomenclature. Results are artifacts. Anything which is not a result is a message. So this is a message. Oh, you have a follow-up question. That is a message, right? Everything is a message. Okay, sounds good. If the Google Calendar agent would give you back a response saying that, oh, you know what? This is when I scheduled it, and whatever, like the actual times of when it's scheduled, what, right? The time frames and things like that. That would be an artifact. So an artifact could be a frigging string. An artifact could be an image. It could be anything. Remember, in messages, you could give images, you could give text, you could give anything, right? So similarly, output could be anything as well. It could be text, it could be image, it could be anything. So it's very open-ended. There's no constraints on how do you communicate, which unlocks like a lot of possibilities. It's crazy. All right. So a task is always created by a client, and the status is always determined by the remote agent. So a task not only has messages, not only has artifacts, but it also has a status. So a task is created by a client. So obviously a client will submit a task to the remote agent, and then the remote agent will give it a status, whether I'm working on it, whether it's done, whether I have some extra questions. So you already see how a lot of our interactions is going to start shaping up. Whenever we were talking to the server, we are going to submit a task. And whenever we get a response back, it could either be a response saying the task is now completed with an artifact, or it could be something like, hey, this task is not completed, but I have some questions to ask. Based on the status of the task, we can figure out what do we need to do next. That's the standard I'm talking about. Okay, a multiple task may be a part of common sessions. I have no idea how this would play out. Don't even ask me. So multiple task may be a part of the common session denoted by an optional session ID if required by a client. To do so, the client sets an optional session ID when creating a task. Now, I know multiple task per session ID sounds like a cool feature. You might even say that, oh, we might even need it here, perhaps, but it's a little tricky. Okay, cool. So agent may fulfill the task immediately. Sweet. It may schedule the work for later. Sweet. It could reject the request. It could negotiate a different modality. Let's say you're giving it an image and it's like, hey, don't do images with me, man. Ask the client for more information. We already saw that. Delegate to other agents and systems. Okay. This is an internal implementation. We don't care about what agent does under the hood. Okay, cool. So even after fulfilling the goal, the client can request for more information or a change in the context of the same task. An example, draw a picture of a rabbit. The agent says, hey, this is a picture. So the picture would be an artifact, guys. And the status would be completed in this case. But the client can still submit another request against the completed task and say, can you now make it red? Okay. Similar to how you work with LLMs, right? When you work with an LLM, you get a response. You can ask a follow-up questions by appending to the messages array. You can technically do that as well, which is great because imagine when this guy gives a response, it doesn't give you the actual details, right? You have to ask it separately. Right? So if it just said, hey, I scheduled it, but doesn't give you the details, you could ask a follow-up question saying, hey, can you give me the details as well, please? So even though the task was marked as complete, you can always ask for more details. I hope this makes sense. Now, this is a spec of a task. This could be too much. I'm going to skip over it. I would strongly suggest you go through it because the spec will define the possibilities. And trust me, all the use case I've had with Fluidcast at least, they all fit in perfectly here. So it's pretty comprehensive, but we are just going to jump ahead and look at an example to make life easier. Unfortunately, MCP, I don't think it has a client SDK yet, but again, the protocol isn't that hard to implement. So yeah, you might have to do it yourself. So we're just going to look at the messages. So, okay. How does it look? MCP is a JSON RPC, which is essentially a standard way of talking. You don't need to know what JSON RPC is. By the way, MCP was also JSON RPC. A2A, MCP, both are JSON RPC. Doesn't matter. But okay, how do we submit that request? Now let's try to model this. How do we do this? How does this guy tell this guy that, okay, do this, right? How does that happen? Let's get into the weeds. So you submit a task. So you give a method called task send. I'm sending a task. Right? You give a task ID. This ID, notice, it's generated by the client. So the client generates a task ID. That's a really important point because especially if you want to follow up questions and things like that on task, you need an ID, right? You need a reference point against what you can follow up against. So yeah, you generate a task ID. Now this literally just looks like OpenAI, right? But it's technically Gemini because this is Google. So you have a message array. But again, when you're sending a task, you're only allowed to give it one message at a time. Okay. So you are only allowed to give one message. It's not a message array. It's a single message. But your role is going to be user and you're going to give paths. Paths could either be type text. It could be type image. It could be, they have multiple modalities. Just go through it. These are your MIME types essentially. And this would be the task you want to give. So here it's tell me a joke. In our case, it would be give me all the tasks. Okay. That's it. And you might get a response back with the status immediately. And you see, the status was thrown in here and the state of the task is completed. And the output here, the joke which we wanted to generate, the output, because it's the joke which is the result, it's an artifact. In OpenAI, we would get, I keep saying OpenAI, but I mean an LLM, okay? In the OpenAI spec, you would get back a message. But just remember, in A2A, if it's the result, you get back an artifact and the artifact name is joke. And obviously you need paths here because an artifact could be part image, part text. It could be, it could be anything, even I don't know what it is, right? So you have an artifact of type text and you have your text here. But again, you can easily imagine if it was generating an image, it would be image. You can also imagine that if there would be image and text in the same artifact, you could do that as well. The point is you create artifacts, right? But sometimes your tasks are long running. For example, let's say, generating this artifact takes a lot of time. And let's say Notion decided that, oh, you know what? I'm not going to do it immediately. I'm going to do this later. So you would want a way to poll the status of a task, right? So you have a command for that as well. You can just say, hey, I want to get the status. And this is where the task ID comes in handy, saying that, hey, give me all the status and give me 10 past messages, right? That's my history length. So you're going to be like, hey, the task is already complete. These are all the artifacts. And these were the last 10 messages. So you can get the status as well. I don't know why this would be so important, but yeah, if you have some task running in the background, it could be helpful just to, query the state of the task and things like that. So you're already seeing something. MCP was a task to communicate, like just to talk. A2A is also just a task to communicate, but it also is stateful. As in MCP, you just send a request, you get a response back. And in A2A, you're kind of like having a full-fledged task management system where you're like, hey, I'm submitting a task, I can query, follow up on a task, I'm getting a result on a task. It's far more comprehensive. I'm not saying you would need every aspect of this. It's just that having that possibility really helps. Oh, wait, I wanted to show you something cool now. Yeah, you can even cancel a task. That's so important. Push notifications. You know what? Actually, let's talk about notifications. So we saw the basic task management system in A2A, right? A very high overview. We did not see the depths of it. I want to now talk about why the task management system, it's not task management system, but the task-based protocol stuff is so freaking cool. What makes the concept of a task in A2A so awesome? Let's look at that. The first one is push notifications. What you could do is, let's say we have this calendar agent, right? And we are like, hey, you schedule these things, and then it will be like, I schedule all of these things. However, maybe what can happen is sometimes some tasks run for really long, or sometimes you might want to treat a task's artifact in a special way, right? For example, here, whenever I go to this calendar agent and it's figured out its final artifact on the final, the scheduling it made, maybe you want to handle it on your backend system separately. Maybe you don't want to handle it here. You want to be like, okay, whenever there's a new invite scheduled or whenever there's something placed on the calendar, you want a webhook. Right? You want a webhook to be triggered in your application and you want to take some actions there. So essentially what you want is, you don't want the response of the schedule here. Instead, what you want is this guy to send a webhook to your server saying that, hey, I just scheduled some tasks, right? I just scheduled some tasks. And what your server will do is, oh, you know what? If any task gets scheduled, always add it to the company calendar as well. Or it could be added to Alexa. Essentially what you're saying is you want to do some specific actions based on the result of an artifact. So whenever an artifact gets generated, let's say an image got generated, you want to store it in S3. Now, technically, you could potentially write that answer in the assistant. Like you could say, whenever I get this artifact back, I should put it in the S3. But now you're just making the assistant more complex, right? Wouldn't it be better if we could just tell this agent that, oh, you know what? Whenever you create an artifact related to generating images or whenever you create an artifact to scheduling something on the calendar, just call a webhook. Call an HTTP webhook. And my server, this could be an agent or this could just be another API. It could take care of how to handle that agent or how to handle that artifact, right? That's push notifications. This is a godsend when you're dealing with long-running agents. So some agents which take really long to answer, like minutes, maybe even days, your assistant is not going to wait for those answers, right? So a better way would be to tell this agent, hey, you know what? Whenever you're done with the result, whenever you generate an artifact, be it after 10 days, just give me an HTTP webhook with the artifact, and then I'll take it from there. So this means you can pause a workflow, you can resume workflows, you can submit artifacts asynchronously to a backend, store it in S3. It just unlocks so many possibilities. That is essentially what this push notification feature is. So client may configure a push notification URL to receive an update from a task, right? So essentially what is happening is, as soon as I submit a task, I'm telling my server that, hey, you know what? Against this task, whenever there's a change in the task status, like an artifact was generated or anything, just call this URL and you have to give it a JWT. So obviously the backend would have Notion, or the backend agent would have to be configured with the authentication scheme to send you a webhook and all that stuff. But this means that you can get asynchronous webhooks whenever certain things change in the task, which is crazy, which means you can make asynchronous systems, you can make workflows. Dude, this is so cool. I mean, this is amazing. This is so cool. Yeah, that's pretty much it about notifications at least. But imagine doing this in MCP. I mean, there's no way to do it. And again, how do you know whether the server supports notifications? If you go back to the agent config, if you go back to the agent card, you can actually check in its capabilities whether it supports notifications or not. Does that make sense? This is like a plus. Very powerful feature. I love it, but that's not the important part. Multi-turn conversations. This is where things start getting really interested. A task may pause execution on the remote agent if it requires additional user input. Like in our case, we had an additional question. We need more input, right? Hey, we don't have a 4-hour block free. It's not technically an additional input, but it's a problem. Essentially, the agent is trying to ask a question to the client. The backend is trying to ask a question to the client. When a task is in the input required state, the client must provide additional input. So there is technically a special way inside the frigging protocol. Like, for example, you submit a task, right? You just said task send, you give it a question. You get a frigging response saying, the state is not complete. It's not working. It's literally input required. It's being so explicit that, hey, you know what? I'm not going to do any other work until you tell me something. And what do you need to tell me something? Select a phone tab. Is it an iPhone or an Android? And then you just send an update. So you still do a task send. So technically task sends are idempotent. If the task ID did not exist, you create a new task. If the task ID already existed, it's like appending to that same conversation. So now you say Android. So you see how you're making conversations. The backend is stateful. And I know Keenan from our community was really excited for stateful backends. This is the way to do it. And this is how explicit it is when it comes to multi-turn conversations. There is no second guessing that you need to talk back to the agent. There's no second guessing whether this is an output artifact or is this something where I need to respond to. It is explicit. And that's what I mean by a standard. It's a standard way of doing multi-turn conversations, which is already awesome. Right? But for Fluidcast, especially because Fluidcast is real-time voice agents, I need real-time responses, right? And yeah, A2A supports streaming support. Again, how do you know whether it supports streaming updates or not? Just go back to the agent card and you just see if this was true. If it's true, you can get responses in a streaming manner. That is so cool. That is so frigging cool. I love it. How does streaming support work? Just remember how streaming works in OpenAI. Instead of saying task.send, like remember earlier we were just doing task send. Now we are saying task send subscribe. Okay. And you only send subscribe if, the streaming support was enabled, right? And now you can just ask a question like you always did. And you're giving it a text along with a file. Again, that's so crazy. And now the response you get back, this is interesting. Just pay attention here. The response you get back is, okay, this is your task. I have a status saying the status is working. The response is not final. So it's not done. So it's not completed either. And now you see what's happening here. You're getting against that same task. The task ID is going to be the same. Against the same task, you're getting an artifact, which is your tokens, as it's being streamed. Whenever you have a client, like OpenAI, it just gives you the delta. So you have to append the individual tokens you get back to form the final output, right? Here you have explicit instruction whether this is the last chunk or not and whether you need to append or not. And then you get section 2, but you see here, append is true, which means when you get the second section, add this to the previous one. It's so friggin' explicit and it's the same artifact. How do you know this is the same artifact? Because the index is 0. It's the same artifact, right? And eventually you get to a point where you're like, last chunk is true. So this is done, append only, and you're done. Yeah, this ID should have been the task ID. We have a bug. This ID should have been the task ID. Oh, they have a bug in their docs. Should we fix it? Let's fix their bug. They have a bug in the docs. Let's see if we can find this easily. Where's their docs? Is there docs here somewhere? Yeah, I want to contribute. Where the hell is the docs coming from? We are not doing that. Okay, you know what? I tried being a good guy. I really tried. I couldn't find it. You guys are not helping me either. Yeah, you know what? It's not working out. I'll try to find it later. We're just going to continue. Okay, cool. So, what's the thing about streaming? Sometimes when you're streaming and you're getting these chunks as response and, all that fun stuff, sometimes what happens is your internet drops. You get disconnected. You can frigging resubscribe. You can literally go and say that, hey, I want to resubscribe to this task. And the server will automatically start sending you all the chunks from where it left off. That's crazy. That's really comprehensive if you ask me. Yeah. I mean, they've thought of every scenario. Like Google being Google, they have thought of every freaking scenario. Okay, one last thing I want to show you. Of course, there's the PDFs and, JSON stuff. Structured output. This is the one last thing which I think is really cool. Actually, you know what? I'm not sure if the way structured output is implemented in A2A is cool or is it unnecessarily convoluted? I don't know. I think we need some more real-world examples to figure that out. But essentially how it works is, okay, right now, we are assuming that all of this would come back as text, right? It would come back as string. But what if you want to say that, you know what? Give it to me back as a JSON object. Wouldn't that be cool? Like how we ask OpenAI to say that, hey, give me a JSON object back. What if my assistant could just ask the agent to give a JSON object back? You can do that as well, apparently. So essentially, whenever you're asking your question, you can attach some metadata with it. That's why I said, go through the protobuf specs. The specs are very elaborate. It shows you the possibilities. But yeah, one thing you could do is you can attach metadata to it. So you could say that, okay, you know what? The answer you give me should be of application JSON. And this is a schema. It's going to be an array. It's going to have a set of items. Obviously, an array has items. And the items will be an object. And these are the properties which needs to be there. So you define the response in JSON schema. That is so cool. And this means that whenever you get an output, okay, this is a little less cool. You get an output as string. But yeah, if you trust your agent, this is going to be JSON, which you can parse directly. So you could technically just ask the agent to give the response back in JSON. Now, unfortunately, this is like a capability which the agent needs to respect, right? The agent should have some ability where it's like, oh, if the user is giving me this metadata, I need to make sure that I give a structured response back. So it needs to be a feature on the agent. How do you know if the agent supports that feature? Technically, there is no way over here to say whether the backend supports JSON or not. You could technically go in the skill and say one of the output modes is, you can give it like a meme type saying application JSON. So one of the output modes is application JSON. And I think that is the only way the agent can say that I support JSON as responses or I support structured output as responses. But it can get a little confusing to implement this. So that's a slightly tricky part. And also one more thing you notice, the schema of the response is described by the client, not the server. So usually in functions, the function dictates what the response type will be, right? Here, because it's an agent, it's literally saying that, hey, you know what, you tell me what format you want the response in and I'll give it to you in that format. That is dope because this means that, okay, if you want the response to be a particular format, you can just ask it in that format instead of saying that, oh, the agent is going to give it to me in this format. Now I'll have to convert it myself. No, you can literally just ask it the format yourself. And that is pretty cool if you ask me. That is amazing. All right. So at this point, I really hope you guys are enjoying the stream. And enjoying this video if you're on YouTube. I stream every Tuesday. So if you want to be live, ask me questions and make it interactive, have fun, and just chill. You can join my streams every Tuesday. I stream at 5:30 Pacific time, and I'd love to see you there. All right. Yeah, and I'm sorry I couldn't get in a lot of code because usually I prefer explaining things with code. But I think a deep dive into just the spec is worthwhile, even though we don't have the code. So we could have another stream on just the coding aspect of A2A, even though that's going to be so complex. That's going to be a hard one. Might need some more time. But if you're interested in a more practical code-driven example using A2A, maybe we could just do this one. Just let me know in the comments as well. So at this point, let's just talk about some pros and cons of A2A. Let's write it down. Why not? Okay, so some pros and cons. Pros and cons is going to be a slightly difficult one. But okay, I think this is hands down very comprehensive. And you want your protocol to be comprehensive. Why? A comprehensive protocol means that they've thought of the edge cases and they've covered it. Like that one classic example, right? If you're streaming a response, but your stream gets disconnected, the ability to attach back and continue from where you left off. Wow. That's comprehensive. They've thought of all the edge cases. And this is Google, guys. They designed some of the best specs on the planet. gRPC, just to name one. Protobuf, flat buffers. These are very well-defined specifications. So very comprehensive, covers all the edge cases. No doubt about it. Second, I'm not sure if you noticed this, but your client doesn't really need to be an agent. Now, I know in the example I showed you right here, the client was an agent. Like this was the A2A client and it was an agent. But technically speaking, because the protocol is so well defined, you can think of a ChatGPT screen, right? Let me open ChatGPT. I'm not subscribed to ChatGPT anymore. I just blocked it because Gemini is so good. I'm a Gemini shop now. I'm a complete Gemini shop now. But if you remember, in ChatGPT, you had these GPTs, right? So technically, each GPT could be powered by a separate A2A server. Why not? This input box is the task which you submit, right? All follow-up questions would come in the chat conversation as it always did. All artifacts could be shown in a separate way. I love the way Sonnet shows artifacts. Like, let's go to Sonnet for that one. Sonnet is pretty good. Good UI. So the questions you send them could be tasks. These things could be artifacts. Like, these diagrams and stuff could be artifacts which could be shown separately on your UI. Messages could be just follow-up questions and things like that. Me submitting a follow-up task could be something like this. So technically speaking, you don't need an agentic client to use A2A servers. You could have a UI similar to ChatGPT and that could talk to the agent directly, which is big. You can't do that with MCP, by the way, if you haven't realized that. And another thing, it supports eventing. Actually, eventing is not the technical words, streaming and task updates. I think this is really important as well because Streaming and task updates are not functional requirements. Those are experience requirements. As in, you want to stream results so that you can show the user as it's being generated, right? So you have something to do that. You need task updates to show that the agent is doing something. Like when you have the cursor thing going on, cursor gives you the individual steps that it's doing, right? That hey, I'm reading a file. Those are just task updates. Those are really important when you're building real world experiences. Yeah, pretty much. So those are the pros. Let's talk about some cons. If you're building an A2A client yourself, if you're building an agentic A2A client like this assistant, if you were the guy building this assistant, it's complex. Building agentic A2A clients are hard to implement. Like I said, you could even have a dumb UI, technically speaking. But yeah, A2A client, I'm not going to justify this. I think it's going to be hard to justify that. But trust me, just because of the possibilities that can happen, like the response you get back could be a follow-up. You'll have to be prepared that, hey, you can get follow-up questions. You'll need to know how to answer those follow-up questions. So if you're making an agentic A2A client, it's going to be a little hard. It's going to be a little complicated. Like I said, I definitely have to build something like that in Fluidcast. So maybe we'll have an example in code really soon. Another problem is actually, forget the clients. I think the first one should be too many moving pieces. I remember when MCP came out, just understanding the protocol was too much for some people. They were like having a hard time just understanding what is MCP doing, what's the scope. A2A does a lot more. It's far more complicated to fully comprehend the nature of A2A and build systems around it. So again, depending on how complex systems you've worked in the past, you might just have a hard time in grasping what A2A is, what feature to use when. There's just so many more moving pieces, right? So it's more complex. And because it's more complex, making agentic A2A apps becomes hard. I think that's the order it should have been. Yeah. And I mean, this is not a con or something, but I just want to point it out because it doesn't sit right with me. Multiple tasks per session. The fact that this is just a possibility in A2A and that your clients might do it. If you're making an A2A server, a client might submit 2 tasks on a single session. I don't know how will the server even handle that. The fact that it's a possibility means that your server needs to handle that possibility, right? I don't know who would do this. I don't know how to interpret this or even act on it. If there are 2 tasks on the session, do they share the same message history? Do they share the same memory? What does that mean? What does 2 tasks on the same session mean? I don't understand this. I mean, and I think this could create some confusion. So I'm just going to point it out. Again, most people will never do this, but I'm just going to point it out because it kind of did not sit well with me. Yeah, let me know your thoughts on A2A. Do you think this is big? Do you think you would use this? You have some use cases for it? I would love to hear that. But yeah, next thing would be, how does this compare to MCP? Like, wait, A2A, MCP, same thing, different things? Like, what's the scene there, right? You should check out my next video for that. So I'll see you in the next one. Like, share, and subscribe if you found this video to be helpful. And don't forget, I am your tech bud. You're on YouTube and hopefully in real life.